Hi there. Welcome to our lecture on Newton's third law of motion. This is Force 3 of Unit 6. Our key ideas: what happens when an object exerts a force on another object, and how do you calculate the momentum of an object, and what is the total momentum after objects collide. So we're looking at action-reaction forces to start out with. So when one object exerts a force on a second object, the second object is going to exert an equal and opposite force in the direction, or an opposite direction on the first object. So if I've got my hand here and I push on it, then this hand is pushing in an equal and opposite direction. So this is true even if we're talking about the wall. We can sit here all day and push on the wall, and we are applying a force on the wall. Well, in order for that wall not to move, it's got to apply that same force against you. So we don't necessarily think of that so much, but it's true. And we call this Newton's third law. So forces are always going to occur in pairs. So whenever you have one force, there's always going to be an opposite force that's interacting with the force that's applied. So here, for every action force, there's an equal and opposite reaction force. So we call the push on the object action force. Whatever that object has, maybe it's the mass of that box pushing back against, maybe it's the force of friction on the floor, that would be a reaction force that's taking place. Forces in a force pair do not act on the same object, and the equal forces do not don't always have to be have equal effects. So just because we have forces that are equal, maybe the object still moves maybe in a different direction based on how we're pushing on that object. So the example we're given here, the action force of Earth pulling on an object and causing it to fall, is much more obvious than the equal and opposing reaction force of the falling object pulling on Earth. So moving from Newton's third law, we're going to look at momentum now. And we're going to start by looking at how to calculate momentum of an object. So if we're looking at movement along a straight line, momentum is calculated by multiplying an object's mass and its velocity. So momentum is equal to the mass of an object times the velocity that that object moves. So we use the letter P to show, or as an abbreviation for momentum. So just make note of that. P equals m times v. So the momentum of an object depends both on mass and how fast that object is moving, or how fast the object is moving. So we define momentum as the quantity as the product of the mass and velocity of an object. So the SI units of momentum are kilograms times meters per second. So kg times m/s. This is our momentum because we are dealing with the mass and velocity. Momentum and velocity will always be in the same direction. Also, we could say the momentum increases as mass and velocity increase. And then the force is related to change in momentum. So we could talk about a Mack truck and a little Volkswagen. The Mack truck having a lot more mass, when moving at the same velocity, is going to have a lot more momentum. However, if that Mack truck were moving very slow and we had the Volkswagen that was going very fast, it is a possibility that the momentum could be equal between those two objects. But in order to be equal, the velocity of the less massive object would obviously have to be quite a bit larger. And then as for a period of time of the momentum's change, it becomes longer. The force needed to cause this change in momentum will become smaller. So looking at a math problem here with calculating momentum, calculate the momentum of a 6 kilogram bowling ball moving at 10 meters per second down an alley towards the pins. So we're given mass is 6 kilograms. This is the unit that we want. Velocity is meters per second. That's also the unit that we want when we're solving for momentum. We might also indicate direction because we're dealing with velocity. Okay, so looking at our equation, momentum equals mass times velocity. Plugging in the mass of 6 kilograms times the velocity of 10 meters per second. Multiply those to get 60 kilograms times meters per second, and it's going to be in a direction, so it's towards the pins. The other item that we have on this is conservation of momentum. So what's the total momentum after an object hits another object? So we've got that collision that takes place. What's the total momentum? So the total momentum of two or more objects after a collision is the same as it was before the collision. So we can also say the total amount of momentum in an isolated system is going to be conserved. So if car A hits car B, we talk about just the system between the two cars. So the total collision force between those two objects is going to be conserved or the same before and after collision takes place. If we do calculations, it's not going to come out to be 100% exact because we lose some of that, some of the value to heat in the surroundings. So, but if we ignore those factors, then it is conserved. And we call this the law of conservation of momentum. That's all I have. Thanks for listening.